In this project, we use a 3mm cable which connects the sound cards of two Android smartphones directly to transmit and receive files. First, the source file in SD card is read as bytes buffer by buffer, and then it will be transferred to data sequence in bits. Any format of file can be used here, such as TXT, Word, etc. The CRC will calculate the check value for the data sequence and append it to the data sequence. After adding the training sequence, guard bits, data length, and file name to the data bits, the in-pile transmitted sequence is modulated at the transmitter. In MATLAB simulation, we design 4 modulation schemes. There are QPSK, 64 QAM, 32 APSK, and 128 QAM. However, 32 APSK cannot get the required transmission rate. 128 QAM can get the desired rate, but it's very complicated to implement in Java. Finally, we choose 64 QAM to modulate the data part in order to increase the transmission rate, QPSK to modulate the other parts to ensure low error probability of these parts to get correct results of cross-correlation. Then, the modulated signal is converted to analog signal through a DA converter. An acoustic channel transmits the analog signal to the receiver. At the receiver, the signal is first converted to digital signal and then demodulated. First, the signal will be through an equalizer. The equalizer will make the channel nearly flat. Then we will do phase estimation and time synchronization using cross-correlation. In phase estimation, we take a portion of the received signal, which is around the training segment, to do cross-correlation with the carrier. This step is to make sure that the received signal is aligned with the carrier in phase. Next, we demodulate the received signal. In time synchronization, the demodulated signal does cross-correlation with the training sequence, and the peak value of the cross-correlation result is the start point position of the demodulated signal. According to this start point, we will get the data length in order to extract the data sequence we need. The received data sequence will be done CRC again. If error exists, the receiver will request retransmission. Otherwise, the data will be converted to bytes and stored on the SD card. Now we finished the real-time file transfer. The system is real-time because we process the received data buffer by buffer. This receiving scheme makes our system able to process the data while receiving, which means we don't need to wait until the whole data is received.
We now demonstrate the working of our system. This phone is the transmitter and this is the receiver. A 3mm cable connects the two phones. Now let's start the application. We begin by selecting the receive option at the receiver first. It is now ready to receive a file. At the transmitter, we select the send option, which opens up a file browser. We select the desired file and say done. The receiver receives the file and processes it as it is being received. We can see on the display area that the CRC check was successful and the reception was error-free. The file can now be viewed in a dedicated folder created by the application at the receiver. Ta-da!